This is a follow-up on the video on Unity multiplayer with AWS services. If you haven't watched it yet, you may want to jump back to it to get some context. This video demonstrates from the Unity side how to establish a continuous connection to the custom server we created, and communicate player actions to the server and other player session clients. For establishing the game's WebSocket connection, I used a library called Native WebSockets that I found on GitHub. I used this because it seemed lightweight and easy to get working. If you'd like to use this library, head over to the Native WebSockets repository, clone it, and then drag the nested Native WebSockets folder into your Unity project's plugins folder, and that's it for the installation. I decided to use WebSockets as it allows for a pretty straightforward solution to establish a continuous connection to instantly send and receive messages between a server and multiple clients. WebSocket communication is also reliable and predictable between clients. There are other communication strategies, or a combination of them, that are probably better suited for high data demand games like a first-person shooter or an MMO, where you have a continuous changing of player location and actions, but that's a little out of scope for this video. I just wanted to provide a jumping off point for devs to get their multiplayer games up and running. Okay, so let's highlight the key functionality to get this to work. I created a sample game and dropped in the multiplayer support through one script called WebSocket Service. It handles the WebSocket connection lifecycle and exposes a few important methods to use throughout the game. The script initializes and manages the WebSocket connection lifecycle as defined by the Native WebSockets library. The lifecycle code for this class was taken directly from the Native WebSockets GitHub README. The findMatch method should be called to open a connection to our AWS server, as it creates all the necessary callbacks like onOpen, onClose, and onMessage. The onOpen callback tells the server that this player session is ready. The game is now waiting on a match. Each time a message is received from the server, it gets passed to the onMessage callback where we process the data. If you look at the processReceiveMessage method, you can see that there are several opcodes that we check for, like playing opcode, which means we found a match and the game has started. I also check for a throw opcode, which doesn't actually do anything but demonstrates that we can receive notifications from actions that the other player performed. Then finally we have the you won and you lost opcodes that tells the player if they are the winner or the loser. The send WebSocket message method is what we use to send messages to the server based on player actions. So for an example use case, if you check in the ball action handler script, we have a throwball method that calls the send WebSocket message method to send a message to the server indicating that this player threw a ball, which then our server sends out to the other players. If we take a look at the block hit function, it is used by the block controller script to notify the server that this player hit the block, and if the server determines that they were first, that player wins. The winner and loser opcodes are sent out to their respective player clients from our server, and then here we process and display the winner and loser messages. Our menu script allows options for finding a match and quitting a game. The findMatch button calls the findMatch method and our WebSocket service script, and the quitGame button calls the quitGame function. These functions just establish a new connection or disconnect an existing one, respectively. During a match, if a player quits a game by closing it, or if their socket connection fails, the server just disconnects all players and ends the game. So to recap, we highlighted how you can use a WebSocket library to communicate player actions and game states to an AWS Lambda server. I know there's a little more to a complete polished game, but I hope this gives you a starting point for your multiplayer functionality. The code for this project and the previous AWS video can be found on GitHub, links in the description. If you'd like to try out the gameplay, hit me up on Discord and we can make it happen. Thanks for watching.